Hello everyone, I'm Rachel Au, a graduate student at New Mexico State University. Today I'm going to give this talk entitled Robot Touch to Send Sympathy, Divergent Perspective of Senders and Recipients. This work is a joint effort. I work on it with my co-authors, Katrina Ling, Marlena Fraune, and Katherine Tsui. Many people live in physical isolation now. In the past few years, I believe we all have lived in physical isolation to a different degree because of the global pandemic. In such situations, we have to rely heavily on online communication. But there's one major problem. Touch is lacking in online communication. We cannot touch the people we are talking to in a video call or video chat. And this makes the communication of emotions a lot more difficult. There's a type of touch called affective touch, which is the type of touch that is used to directly communicate emotions. For example, to show love, we may hug the person. Or when we feel angry, we may push or shake the person to show our anger. So in this work, we want to see if robot can help fill the gap of online communication and how robot can improve online communication. There are existing robots with touch functions such as HuggyBot, HugV, Paro, and some other robots. In previous work studying these robots, researchers mainly focused on touch without emotions, or emotions are only implied. They also mainly focus on one-way touch, which means touch from human to the robot or touch from the robot to the human. But in the current work, we want to study robot-mediated touch sent from one human to another human. This means that a person controls a robot to send touch to another person. In our work, we also focus on one type of emotion, which is sympathy. Sympathy is the sorrow or concern you feel when you see other people suffering. This is an important emotion in social bonding because it helps people to feel closer with one another. Sympathy can be shown with touch, usually by rubbing, stroking, hugging, contacting the shoulder, arms, and hands with light intensity. We've conducted 2 online studies to study how robot can be used in online communication to help conveying emotions, mainly sympathy, and we want to see if it can in turn promote social support and make people to feel closer with one another. Study 1 focuses on the perspectives of sympathy senders, and Study 2 focuses on sympathy recipients. We provide open access to the study materials and dataset of both studies on our Open Science Framework website. In both studies, we use MyCobot, developed by Elephant Robotics. This is a robot with a very long arm, and it can move in different angles. We want to use it to mimic different types of human arm movements. We have also added a soft, fuzzy sock on top of the robot arm to make the touch look more comfortable. In Study 1, which focuses on the perspective of touch sender, we recruited 171 US participants and 170 Japanese participants, with a total of 341 participants. In these studies, participants name a friend they feel comfortable having an online chat with, and they imagined a friend talking about a negative life event they're experiencing. Participants then send different responses to comfort their friends. The first one is a type of short text they type to the friend. They also selected different GIFs with sympathy theme to send to the friends, and they select different forms of robot touch to send to the friends. These 3 responses were manipulated within participants. These are the GIFs we provided to participants to select with. And these are the robot touch videos we created for participants to select for the robot condition. And this is what we have found. For the short text participants sent to their friends, the main theme is that they want to affirm the effort of their friend, show love and care, and show self-care concern. These are the most commonly chosen GIFs for participants. And these are the two most commonly chosen videos of robot touch. They are patting and rubbing on the shoulders. When asked to rate how much they like each response they sent, participants showed a preference for short text and GIFs over touch, and both comparisons were statistically significant. In Study 2, we shift the focus to Sympathy recipients. We recruited 170 US participants and 170 Japanese participants, with a total of 340 participants. This time, participants also report a friend that they feel comfortable to have an online chat with, but this time they themselves report something that they're experiencing that negatively affect them or worried or annoyed them. And then they imagine sharing this live event with their friends using an online chat function. And they imagine receiving one of 3 responses from their friends, which depend on the experimental condition. So these were manipulated between participants. They either receive a short text, a GIF, or a robot touch. The results showed that participants who receive robot touch actually perceive more sympathy from participants who receive short text. There were no difference between the GIFs and touch condition, and interestingly, the effect only held for participants who perceived the touch as sent from their friends but not from the robots. There were a similar pattern of results in perceived social support. Participants who received the touch also perceived more social support from their friends compared to participants who received short text. There were again no differences between GIF and touch condition, and the effect also only held for participants who received touch that perceive it as from their friends but not the robots. So interestingly, the 2 studies altogether show very different views of robot-mediated touch senders and recipients. Touch senders have a preference of more traditional ways of sending sympathy to their friends, such as using GIFs and short text. But for touch recipients, they actually perceive more benefits from robot touch compared to short text. A speculation we have is that it may be a unique feature of robot-mediated touch. In human-human touch normally, both the sender and the recipients receive some kind of tactile sensations. But in terms of robot-mediated touch, the senders are actually less involved in the process of touch. They may be only pressing a key on the computer to control the robot to send touch, so this may make them harder to see the benefits of the touch itself. One limitation of the study is that we mainly ask participants to imagine receiving or sending the touch, but they do not actually experience any touch. So the next goal is to conduct a real-world in-person study to have participants actually experiencing the touch and report how they actually view the touch after experiencing it. Thank you very much. This is my email. If you are interested in this work, I'm very happy to further discuss it with you. I would like to again thank my co-authors and other researchers who have contributed to this work. I would also like to thank Toyota Research Institute who have provided funding for this work. Thank you very much.